I'm Sneha Chakrapani from the Department of Chemical Engineering, Auburn University. Today's topic of presentation will be polylactic acid, or in short, PLA. PLA biodegradability is depicted in this picture where biomass sources containing starch are fermented into lactic acid, which is further polymerized into polylactic acid. Polylactic acid is used to produce commodity products that degrade and go back into nature. Increased demand for fossil fuels and challenges in waste management are driving the focus towards biodegradable polymers, and this is shown in the picture on the left. The scheme on the right shows bio-based, biodegradable, fossil fuel-based and non-biodegradable polymers in 4 quadrants, and PLA lies in the first quadrant as it is bio-based as well as biodegradable. The first recorded synthesis of low molecular weight PLA by polycondensation of lactic acid was recorded in the 1800s. In 1932, Wallace Carothers developed a method to polymerize lactide into polylactic acid. In 1954, DuPont patented this method. Until the 1970s, PLA was vastly used as a biomaterial. The 1990s saw its commercialization and foray into the packaging world. The lactic acids are precursors to PLA production, but the actual polymerization involves lactide stereoisomers, each of which produce PLAs of different properties. The first step in the synthesis of PLA is the bacterial fermentation of starch from sources like corn to produce lactic acid, which would further be purified. The commercially used polymerization technique is the ring opening polymerization of lactides using metal complex as catalyst and lauryl alcohol as initiator. As the scheme shows, the lactic acid is polycondensed to form oligomeric lactic acid, which is further depolymerized to give lactides. Each stereoisomeric lactide gives rise to different PLA polymers with different properties, and hence they find different end uses. Stereochemistry, thermal history, and the molecular weight are seen to affect most other attributes of PLA. The glass transition temperature is around 60 degrees C, and the melting point ranges from 130 to 230 degrees Celsius depending on the PLA structure. The Tg and Tm are strongly affected by the optical composition, primary structure, thermal history, and molecular weight. Crystallinity affects the barrier properties of PLA, which further determines its use in the food packaging industry. Crystallinity influences hardness, tensile strength, stiffness, and the melting points. PLA polymers range from being soft and elastic plastics to stiff and high-strength materials based on their structure. The tensile strength and elastic modulus of PLA are comparable to that of PET. All in all, PLA is a transparent thermoplastic biodegradable polymer. PLA's advantages and disadvantages. Eco-friendliness, biodegradability, biocompatibility, and non-toxicity promotes its usage in the packaging and biomedical applications. Better thermal processability compared to other biodegradable polymers like PHA, PEG, and PCl is another advantage. Nearly 50% less energy consumption to produce PLA when compared to the fossil fuel-based polymers is a huge advantage. The drawbacks would be poor toughness, low heat resistance, slow crystallization rate, and hydrophobicity. This picture on the right shows PLA from the source to end use as a 3D printing filament through extrusion. Like other polymers, extrusion and injection molding can be used for PLA to produce commodities. Injection stretch blow molding produces bottles. PLA polymers can also be stretched into films, sheets, and filaments. Thermoforming is used to produce PLA containers like food trays and cups for short shelf life product applications. Figure on the left shows that PLA stands as the second highest produced biodegradable polymer with nearly 200,000 tons having been produced in 2016. On the right, we see that out of a global production of all bioplastics, 5% is occupied by PLA. This figure here shows that the major market for global lactic acid is occupied by packaging, followed by textiles, agriculture, transport, electronic, and other sectors. NatureWorks LLC is said to be the major producer of PLA today. These are the references that I have used. To conclude, PLA polymers have been continuously researched upon, and various bio-nanocomposites have today become available as a green material for a sustainable future. Thank you.